Hello and welcome back to the Townet team update for November. You're here with me, Follow, and without further ado, let's get into the development update for the month. Over to you, Karim.
Welcome everyone to the November update for the Tau development team. Andrei this month has overhauled the P2P stack and has migrated from some custom implementation to a production grade version based on live P2P and Trio async library. He removed some legacy shim code and refactored the network service for added reliability and scale. He also implemented persistent node identity with file-based keys. He also strengthened the networking with gossip subpropagation, block sync fallback, memory pool replay, and peer connect disconnect notifications. And the next major step for update is moving towards a Kademlia-based distributed hash tree. So you see there's a lot of progress there on the testnet front. We've also made the testnet repo public for those who would like to take a look at it. Um, David last month has wrapped up the BitVector implementation, and on a suggestion from Ohad, he has made some major improvements to the Tau grammar implementation that we call polymorphic grammar. Basically, the idea is that to make our grammar independent of all the base Boolean algebras. And the goal is to make it easier in the future to introduce new Boolean algebras to the Tau language. This was a major overhaul, and we didn't quite anticipate it. That's why it delayed the release of bit vectors a little bit, but now it's almost ready and ready to go out. In the process of implementing polymorphic grammar, David has also had to make some improvements to the type interface. He also made improvements to the CVC5 implementation itself to support this new polymorphic grammar implementation. On the normalization side, Lucca has been working on enhancing the anti-prenixing algorithm on guidance from Ohad, who gave him some last-minute improvements to be made. He has also assisted David in fixing some bugs in the BitVector implementation. He also helped with the switch to the internal type representation to trees and introduced a more advanced procedure to propagate information from one equation to all other equations in the scope. Finally, he also worked on the preparation of the merge. He worked on integrating bit vectors and the new anti-prenixing normalization algorithm. Last but not least, Tomáš has been working closely with Lucca on some performance enhancements for Tau. In particular, he worked on a feature that stores and caches properties at all Tau tree nodes to avoid unnecessary traversals of the tree. He also collaborated with David on integrating bit vectors with the new Tau tree implementation. That was a major effort. And on refactoring and integrating the new type interface. On the repo side, he reworked our CMake scripts to make them take advantage of parallelism to help speed up the build system, because we picked up some more dependencies recently with CVC5. He also enhanced the handling of shared libraries from submodules. In all, basically, you will see a lot of updates this month to the main Taolang repo as we basically merge some major features that have been in the pipeline for a long time. We are aware of some bugs that this will cause, but we're working on very diligently on fixing those bugs and getting the Tau language back to full working order. That's it for the month of November. Thank you, everybody, and see you next month. Bye.
Thank you very much, Karim. And I'll pass it over to you, Tomáš.
Hello everyone, I've been working on tree node properties with free variables caching. Properties is a new structure we pair with a tree node, and it will contain various information about node's subtree to prevent traversing the subtree whenever we want to find out anything. It is a form of optimization or caching. Currently only a list of free variables contained in a subtree is stored there. We did a big merge of new features into main, so I've been helping with fixing issues. I was helping with integration of bit vectors with the new Tau tree API, and also with integration and refactoring of type inference. I've updated CMake configuration and build scripts. I've added a better support for parallel building. Tau uses half of available cores by default, and it can be set by providing a CMake option Tau build jobs or Docker build argument build jobs. I've also improved handling and local installation of dependencies we built locally, like CVC5 shared library. I was also looking into simple way to use CLang in our build scripts, and also to add automated tests with CLang. I've also created a helper script for managing building Tau with Docker, and currently I'm working on Tau build on Windows with regards CVC5 dependency. That's all from me this month. Thank you.
All right, amazing stuff. And over to you, Lucca.
Thank you, Fola. So as Karim said, most of my month has been spent in improving the normalization algorithm, which is internally called the untyped prenex algorithm. And that included, for example, a caching infrastructure, but also several bug fixes and an advanced procedure to propagate information from one equation into other equations in scope. If you know that something is 0, you can use this information in other places. This, of course, can also be done by some kind of equation reasoning machine. We also have that, but there are cases where the formulas grow too complex. So merging information becomes easier than finding it explicitly. Then on the bit vector implementation, in order to prepare it for the merge, I helped on David's side to fix certain bugs that were connected to normalization and the satisfiability algorithm that we were aware of. And on the process, it was realized that the current type representation, which was handled as strings, would introduce some inconveniences in the long run, because we now have a lot more types in our system. For example, each bit with the bit vector can have introduces its own type. And for this reason, and also for the forthcoming function treatment within the Tau language, we decided that it is best to handle type information by trees, because a tree naturally can record all of the type information. This was a major switch because the string type representation has been there for a long time, but it was successful without major hiccups. And lastly, I have always prepared the new untyped prenex algorithm with the bit vector implementation in mind, because we were developing these features on different branches, because they weren't ready to be merged earlier. These considerations are now being tested in practice, that now that the bit vector implementation is on our main branch on the Tau language repo, and I'm currently making the final changes to make the normalization algorithm work with it streamlessly. And yeah, thank you very much. And I'll pass it back to Fowler.
All right. Thank you very much, Lucca. I'll pass it over to Andrei for his update this month.
Hello everyone. This month I continued my work on the networking system of our blockchain. Specifically, I migrated the library P2P implementation that we had to a production grade full-scale library P2P integration that involved moving to a trio asynchronous framework that is used within the native library P2P. It made me rewrite over 2000 lines of codes, but it worth it since we now have a high quality networking system. Also, I implemented a persistent node identity system based on ED 25519 encryption with a file-based key storage, so nodes now after a start keep their node IDs. I had to improve our gossip system to not only be more reliable and productive, but also to use our now almost fully implemented Kademlia DHT system. So now gossip subsystem propagates blocks transactions to connected network, but if they don't have any connected nodes, it falls back to DHT routing table. As for DHT front, it's still in progress. I had to actually write down the architecture implementation of this system since it's quite complex. And currently I'm moving from a memory-based peer table to a distributed peer hash table storage. So aside from this, I wrote more tests because we need to ensure everything is like reliable. And that's it for today. I'm looking forward to wrap up the DHT system soon and move on to our final stages of Tau Testnet Alpha implementation that surely needs to involve broad integration with Tau Bitvector's system. Thank you for your enthusiasm. See you next month. Bye.
And I'll pass it over to you now, David.
Thank you, Fola, and hi everyone. This month I've been working in the new polymorphic grammar in type inference improvement and fixes, CVC5 interaction improvements, code grammar cleanup, and general improvements and fixes all around the code. Regarding the polymorphic grammar, the idea was suggested by Ohad, and more or less is to have a grammar that is independent of the Boolean algebras, regardless if they are atomless or non-atomless. This implies to unify the current supported non-atomless Boolean algebras, SPF and Tau, and the atomless bit vector one. Okay. In particular, what I have done in this regard is to remove all the parts of the grammar related to bit vectors. Also, type all the terms that we have in BF formulas. For example, right now they are typed. That implies that I need to change the hooks and also the builders to propagate all the type information accordingly. And I have also removed all the builders that were no longer needed, mostly related to bit vectors. And I have added a bit vector grammar as we have a grammar for SBF. Okay, we need to do a similar treatment of both Boolean algebras. And apart from that, I have updated all the syntax in all the tests that we have accordingly to the new grammar. Regarding the type inference improvements and fixes, I have done several improvements, mostly related to adding, for example, the type inference for symbols. Previously, as we have, let's say, specific symbols for bit vectors and SBF and tau Boolean algebras, we didn't have ambiguities. But right now, for example, if we have an upper sum, it could be meaning the conjunction in the tau or SBF setting, or it could be the conjunction in a bit vector. So we need to do some type inference for all the intermediate symbols that we have in the formulas. Apart from that, I have had a global scope to supply to the type inference, let's say, a general scope with the variables that we need. For example, that could be useful in when supplying input-output variables to the type inference. And I have also type, for example, the true and the false constant that previously were untyped, and right now they are typed according to the corresponding Boolean algebra. Let's say tau, SDF, or whatever. That was needed because I needed to store the type for processing then during the bit vector evaluation in the case that we have formulas related to that. I have also support to top level BF terms typing. The idea was that we need to type also BF formulas, not only double BFF formulas, and that was related to the REPL, because in the REPL we have BF formulas and we need to type them properly and make type inference over them. So I have added that functionality. I have made minor changes in type inference and add support, a primitive support to type inference in recurrence relations. Regarding CBC5 interactions, I have made a few changes, mostly related to, as I said before, to the processing of true and false in the formulas, 1 or 0 in the formulas. With respect to the code and the grammar cleanup, I have removed huge amounts of code that were that way kind of not used any longer. And also I have removed a lot of things from the library. In particular, I have removed PF rules, WFF rules, libraries, and things like that were remnants from the old rewriting system that right now is not used anymore. And also I have removed all the code related to a strong normalization form because we are not using it. And I have made few general improvements and fixes here and there. And that's all for my month. Thank you very much for listening. Back to you, Fala.
Thank you, David. That was excellent. Thanks so much. And last but never least, Ohad.
Yeah, so I was continuing to work on the problem with improving performance for tables. It's really a nasty problem, and I thought I solved it for like 1 or 2 times this month, but the solution was not complete. Luckily, I still have more ways to go, and yeah, I hope to have a full solution for this, so we will not need to go for fallback solutions. Yeah, hopefully I will be able to announce its completion next month.
Amazing. Thanks, Ohad. And yeah, thanks to the team. Excellent job getting bit vectors out this month. And thank you to you guys for tuning in and for all your Q&A questions on the previous video, but always appreciated. And yeah, please continue to follow us, support us. On Twitter, we are tau_net, and on Reddit, it is tau_net Agrs. AGRS is the ticker symbol of Agoras, obviously. So yeah, follow all of those groups and yeah, be in with a chance to win something nice. And yeah, we'll see you on the other side. Thank you so much. Cheers. Bye.